Hi folks, my name is Bartek and I'm from the Deno team, and welcome to Roll Your Own JavaScript Runtime. Shortly about me, I started contributing to Deno in 2018, and then I've become the employee of the company in late 2019, and I've been with the company ever since. I'm currently leading the Deno CLI team, and should you have any questions or follow-ups, feel free to reach out with one of the links provided here. So in this talk, we're going to talk a bit how to create or roll your own custom JavaScript runtime. We're not going to be doing this from scratch. This talk is based on a couple blog posts we did in the past. We created a small JavaScript runtime called Run.js, and you can follow the links and the recording here if you want to learn a bit more about the history of the project. Well, in our opinion, it's quite easy to get started if you wanted to create your own JavaScript runtime, thanks to the technologies we can now use, which are the V8 engine for executing JavaScript, but also some of the infrastructure the Deno team provides. So without further ado, let's jump right into it. But before we do that, we need to learn a bit more about Deno itself. So Deno is a JavaScript and TypeScript runtime. It aims to be fun and productive to use. Deno supports importing source codes from a file system from remote servers using HTTP or HTTPS protocol. And we also support NPM imports using these NPM colon specifiers. Deno is a TypeScript runtime in a sense that it's not needed to explicitly build your TypeScript sources to JavaScript before executing them. Deno can take care of that for you. It can transpile the sources, but it also can type check them. And Deno is built using Rust and using V8 JavaScript engine. So in one sense, it's very similar to Node.js because we both use the same V8 JavaScript engine. However, Deno uses Rust for its native code, while Node.js uses C++. Deno comes with batteries included. We got a lot of tooling that allows you to get up and running in seconds. You got formatter, test runner, linter. You can even create a self-contained binaries. That is, you will package all of the source code you provide and then give you a single executable file. It's kind of similar to the PKG NPM package you can use. Deno is also very heavily invested in web APIs. We've got a lot of them, most notably Fetch, Text Encoder and Text Decoder, Blob. We got support for WebStreams API as well as Web Worker API. There's many, many more of these APIs, and I strongly suggest you visit the MDM page for the API you're interested in and see if Deno supports the API. So Deno in Rust is, we need to understand a bit of history here, in that the first iteration of Deno, the first prototype, was not really written in Rust. Instead, it was written in Go. However, due to the nature of Go, that is garbage collected, just like JavaScript, it was decided that we should go away from Go so we don't run into a situation where two garbage collectors are contesting against each other. And so Deno was rewritten in Rust, which is a low-level language or systems language that doesn't have a garbage collector. And I can say that this is probably the most influential decision ever made for the Deno project. Rust allows us to move very quickly, and it allows us to leverage a huge ecosystem of the crates available. Most of the crates are very high quality. For example, an HTTP crate that implements the HTTP protocol is very well tested and it has a great coverage. So we're very confident using it that we'll be adhering to the defined protocol. And last but not least, building Deno is really a breeze. Since Deno is fully integrated with Cargo, which is Rust's build tool or build system, it's just a one command to run that will build your whole Deno binary, including V8. but not really. We don't force you to build V8 yourself. Instead, we do that in our CI pipeline so that you can use already pre-built binary archive, which saves you a lot of hassle since V8 is a huge project that takes quite a long time to compile. Another thing is that Deno is not a monolith. Rust provides you with an easy way to factor out pieces of your code to so-called crates. Crates are the equivalent of NPM packages. So these are self-contained and reusable libraries that you can download and use whenever you want. And Deno, the CLI that you can download, is actually a collection of these crates that is intertwined together, and they are made to work together very well. One of the consequences is that we actually, at Deno, here at Deno Company, we don't actually ship just one runtime. We actually ship two different runtimes. We have the Deno CLI, but we also have Deno Deploy, which is our cloud offering. These runtimes are very similar, however, they are not identical. Deno CLI is geared towards local development and deploying your code on your own server or Lambdas, while Deno Deploy is geared towards being deployed to cloud native containers and such. So as a consequence, you as a user can choose which crates and APIs you need, and then you can mix and match them to roll your own runtime that fits your needs. So back to our Run.js example runtime. What can it do right now? Well, it's just 140 lines of Rust and 37 lines of JavaScript, so that's not very much code, but it already has a support for ES modules. It can transpile JavaScript to TypeScript on the fly just before execution, similar to how Deno can do it. We got an API to read a file, an API to write a file and delete a file. We got some rudimentary console API, so we can do console.log and console.error. And we have a very basic fetch API. So it looks like fetch, but it can only really do GET requests. However, with only 180 lines of both Rust and JavaScript, I think this is pretty phenomenal. So let me give you a super quick demo of the Run.js runtime. So I am in the repository that was already linked to you, and we can do cargo run -- example.ts. So we'll be executing a TypeScript file right here, and we got hello Run.js as well content from fetch. So if we decide to inspect our example.ts file, we can see that it uses console.log. Then we got an interface, so that's definitely TypeScript. And then we do await run.js.fetch. So we're also using top-level await here. And sorry for the squiggly lines, but it seems my VS Code setup doesn't understand it here. All right, so let's jump into some actual interesting things. So why would you want to use your own JavaScript runtime? So there are a few use cases. First of them is running untrusted code. So you might not believe us shipping Deno that it's totally safe to run untrusted code. So you might want to run it inside a container. However, now you got a JavaScript runtime and then a container. So there's a bit of slowdown you can expect and resource utilization from doing this double wrapping or double sandboxing, because remember, V8, the JavaScript engine, is already a pretty good sandbox. So you might want a limited set of APIs, but on the other hand, you will use much less resources, which leads us to the second point that you might be resource constrained. So Deno ships with batteries included. We got a lot of tooling in the CLI, but sometimes that binary might be too heavy for you, or you might not need every API that we provide. And we provide many of them. You can interact with file system, you can do networking. There's a huge implementation of various web APIs, but if you don't need them, maybe you can just use a subset of them resulting in a smaller and slimmer binary. Or lastly, maybe your project could benefit from essentially shipping a self-contained single binary. You can already do this with Deno, but sometimes you maybe want to customize it a bit more, or again, remove some of the fat that is not needed in your particular use case. Right here, I linked you to a project of mine, a side project where I try to wrap ESLint into a binary file that uses the same technologies we're going to be using in this example. Okay, so let's actually do some coding. Let's do something a bit exciting. So I think we may try to implement a setTimeout API in Run.js. Of course, this will not be the same setTimeout API you can see in browsers or in Deno or in Node.js because, well, this API is really easy to grasp and use. There are a lot of intricacies to it. What I want to do is essentially implement setTimeout in a way that will take a delay in milliseconds. It will take a callback and then just fire this callback. But we will skip validation, ensuring that everything is properly adhering to WebIDL and so forth and so on. All right, so let's jump right into the code. I'm going back to my VS Code. So let's start by removing this example and let's try to do setTimeout. And I'm going to do, I'll make this bigger for you. I'll do hello world from timeout. And I want this to fire after a second. So the delay we pass is in milliseconds. So 1000 milliseconds is a second. And now if we try to execute this code again, and let me make this bigger for you again. So we executed our example.ts and got a reference error. setTimeout is not defined. Well, this is expected. setTimeout is not built into the JavaScript engine. Instead, it's a web API or built-in API in Node.js. But we don't have it here. We need to implement it ourselves. So let's do just that. I'm going to drop into the runtime.js file, which is a file in which we implement all the APIs available in our Run.js example. So as you can see here, we are assigning to global.this.console a console object, which, oops, I don't want to see the typings. I want to see the actual object. Our console object has log and error function. And then we're assigning global.this.run.js with run.js, which contains the 4 APIs we already talked about. So let's add another one. This time it's going to be global.this setTimeout. And our setTimeout needs to accept 2 parameters. The first one is the callback, and the second one is the delay in milliseconds. So how are we going to do that? Well, Copilot is jumping the gun here, but that's not exactly what we'll do. We need to call into Rust to do something that will wait for the given delay, and only when we've finished waiting, we will fire out the callback. So let's start by adding, by calling core op async, and we'll call it offset timeout. Sure, thank you, Copilot. And then we'll do delay as a first argument. That seems reasonable. And then we want to fire the callback. So yeah, that's pretty much it. Okay, so what will happen if we just try to run it now? Oh no, a typo. It says ops name is not a function. Well, that is expected. So we just try to call a random function from JavaScript, and this function is supposed to be defined in Rust. However, we haven't defined anything yet. So let's fix it right now. I'm just going to copy the name of this function, and I'm going to go to the main.rs file. This is the file that actually implements our whole runtime. As I told you earlier, this whole file is just 140 something lines. So if we scroll to the top, we can see that we got an async function that is opWrite file. Then we got opFetch, opRemove file, and opRead file. These are the 4 functions that were also defined in our JavaScript runtime code. So you got read file here, write file here, remove file, and fetch. And let's just use one of them as an example to provide our offset timeout. So I'm going to start with defining the op attribute. The op attribute is coming from Deno, so this is something we provide for you. Our offset timeouts will return our result. This will be just identity, and then we'll return any error. But we don't really need this error here, but let's just keep it. So the return value will be okay. And now let's actually do the fun part. We need to somehow sleep for given delay, which I haven't passed here yet. So we got delay, which will be U64. And now I'm going to leverage the fantastic ecosystem of Rust crates to actually asynchronously wait for the given delay. So I'm going to use Tokyo for that, which we already use in another API. So I'm going to use Tokyo, time, sleep, and now I need to pass a duration. Duration comes from std time duration, and now I need to create it from milliseconds. Sure. Whoops, seems like my IntelliSense is acting up. So we're going to sleep for a duration taken from the delay variable defined in milliseconds, and then we're just going to await it. So will this actually be enough? Oh, sure, we don't need to use a question mark here. So we defined this in JavaScript, we defined this in Rust. Will it work now? Let's try. Oh no, it's still not working. Well, even though we created this function, we haven't really told our Deno crates to use it. So we need to register it here with our extension. And I'm just going to say offset timeout decal and run it again. There we go. We just waited for a second and we printed something out to a console. That's pretty awesome for, what do we have here? 1, 2, 3, 4, 5, 6 lines of Rust code, and then we got another 3 lines of JavaScript. So yeah, here you got setTimeout, a very basic implementation of setTimeout working. So let's jump right back into the presentation. Yeah, so we created a minimal setTimeout. I think this knowledge, even though it's very minimal and it only took us a few minutes, should be enough for you to be able to keep adding more APIs that you might need. So maybe you'd like to create a plugin system for your game server in JavaScript. You can use Deno's crates like we saw in this run.js example and add some more ops to provide the plugin system. The thing is that Deno, even though is a JavaScript and TypeScript runtime, we also give you a lot of infrastructure if you want to drop to a lower level and do something that is really tailored and for your needs. So you can use the same infrastructure we use to implement web APIs or file system or networking, but you can pick just some of them that fit your needs. And to be honest, the possibilities of what you create with these infrastructure and writing out more on your own is just endless. You're limited by your own imagination here. We're going to keep doing these blog posts and recordings for how you can roll your own JavaScript runtime with more and more features in the future. So please stay tuned for the next part. And that's it from me. I'm sorry that it was so short and I had to speed run through it, but I hope you found it interesting. All of the source code, all the 9 lines that we did here will be available at this repository. So please drop by and visit it. And again, if you have any questions, I'll be more than happy to answer them. Shoot me an email or send me a DM over Twitter, and make sure to visit our website. Thank you for having me here, and I hope you enjoyed this talk. Till the next time.